Elementary Algebra, Final Assessment 3, Review. Questions 18 through 20, Outcome 3, Notation. Simplify. Write the answer with positive exponents. Question 18, we're given p raised to the third power divided by p raised to a negative 6. We want to make sure that we clear this negative exponent. Let's do this by separating the p to the third power from the p to the negative 6. We'll do this by pulling out the p to the third and just putting it over a 1. Multiplying to that, a 1 over a p to the negative 6. Now if you look back, I haven't really changed the problem. P to the third times 1 is still p to the third. 1 times p to the negative 6 is still p to the negative 6. I've simply pulled them out into individual fractions. Now that I've done that, I can go ahead and get rid of this negative on the p to the negative 6 by taking its reciprocal. So I'm going to come over again one more place, and I'm going to copy that p to the third over 1 as it is, but the p to the negative 6, I'm now going to rewrite this as p to the 6th power over 1. By taking that reciprocal, I've cleared my negative sign off the 6. Now I can clearly multiply across. P to the third times p to the 6th is going to be p to the 9th power, 6 plus 3, over 1. And continuing on to simplify this, p to the 9th over 1 is going to be equal to just a simple p raised to the 9th power. Now we're asked to divide the monomials. In question number 19, we're given a negative 24x raised to the 4th power, y to the 5th power, z to the 2nd power. Overall divided by 3 times x to the 10th power times y times z raised to the 7th power. So let's start by dealing with the two constants. We have a negative 24 divided by 3. This is going to create a negative 8. Moving on, let's go ahead and distribute or divide our variables. We have an x to the 4th power divided by an x to the 10th. When we're dividing, we're actually taking a subtraction. So we're taking that 4 from the numerator's position and subtracting the 10 from the denominator's position. On the y position, we're taking the 5 from the numerator's position and the 1 from the denominator's position. Even though we don't see a 1 on the y, there is a 1 present, minus 1. And then from the z position, we're taking the 2 minus the 7. So when we simplify this, we end up with a negative 8x raised to the 6th power, y raised to the 4th power, and a z raised to the negative 5th power. Now, like in previous problems, we don't want to see a negative on our variable, so we're going to clear those. We're going to do just like we did on question 18 and separate each of these into individual fractions. So we're going to take this negative 8 out and put it over a 1 times this x raised to the negative 6th over a 1 times the y to the 4th over a 1 times the z to the negative 5th over a 1. Now again, if you just look back at this, if I were to pull these back together, this negative 8 to the x to the negative 6 to the y to the 4th to the z to the negative 5th, I just have what I have above, the previous one. But now that they're pulled apart and separate, I can come in and take the reciprocals of the variables that have the negatives to clear those negatives. So I'll leave the negative 8 over 1 just as it is, but I'll take the reciprocal of the x to the negative 6th over 1. So now I have 1 over x to the negative 6 times, I'll leave the y to the 4th just as it is, copy it down, times, I'll take the reciprocal now of the z to the negative 5th. So I end up with 1 over z to the 5th. It's a positive 5. Oops. Little error back here. I put a negative back on my 6. on my x when it's just supposed to be an x to the 6th power. Now I can pull all of these back together. So a negative 8 times a 1 times a y to the 4th times a 1 from the numerator's position is going to leave me with a negative 8 y to the 4th power over a 1 times an x to the 6th times a 1 times a z to the 5th, which gives me x to the 6th times z to the 5th for my final answer. Question 20 says, use long division to divide the polynomial. So we have a 2x to the 3rd minus a 5x to the 2nd minus a 4x minus 30 being overall divided by the binomial x minus 4. When we have a problem or presented with a problem like this, we're going to begin by dividing the first term in the dividend by the first term in the divisor. So that means we're going to look at this 2x to the 3rd, which is the first term in the dividend, and then look at the divisor, the first term, which is x. We're going to take those first terms into a division problem. So we're going to come down and take 2x to the 3rd power and divide it by an x, which equals 2x to the 2nd. Another way of looking at that is in a fraction form, so 2x to the 3rd power divided by x, which equals 2x to the 2nd. Now the reason we did this was to find our first term that we'll need to distribute through to the binomial in our long division. So we found that value to be a 2x to the 2nd power. You notice that I put it over the second term. That's because, just like in long division, if you had a digit that took two numbers, you couldn't divide it into a single number digit. So for example, a 10 would not go into a 2. So you would have to move over to the next value so that you could actually divide that 10 in. Same thing here. I've got two terms. I have to move over to the second one to actually get that binomial divided in there. Once we determined that first term by taking that first position, that 2x to the 3rd, divided by the x, which gave us a 2x to the 2nd, we write it to the top and then redistribute it through. So we take a 2x to the 2nd times an x. That's going to give us 2x to the 3rd. At this point, stop. When you distribute the first one, look, is what you created coming out exactly the same as what is above? If it didn't, you need to go back and recheck your math, because they should come out identical, because we want these first terms to 0. Now come back and distribute the 2x to the 2nd to the negative 4. So we end up with a negative 8x to the 2nd power. Just like in long division now, we're going to subtract. So a 2x to the 3rd minus a 2x to the 3rd is going to come down to a 0. A negative 5x to the 2nd minus a negative 8x to the 2nd. Right? Another way of saying that is a negative 5, and with a minus and a negative makes a plus. So a negative 5 plus 8. They're opposites, so subtract them from one another and keep the sign of the larger. In this case, it's the plus 8. So plus 3x to the 2nd power. All right, next, like in regular long division, we'll pull down the next value, which is the minus 4x. Following the same rule as before, we're going to take the first term that's showing up down here under the dividend and divide it by the first term in our divisor. I'm going to bring that over to the side here for the moment. So that first term in the dividend down here is 3x to the 2nd. The first term in the divisor here is x. So when I divide 3x to the 2nd by an x, I'm left with a 3x. So this becomes my next term. put in it up here above. So I put it over the next term in the sequence, over the 4x. So I end up with a 3x to the second power. Now I'm ready to distribute this through. So 3x to the second times an x. This creates 3x to the second power. Again, stop. It should match the value that's already there. If it doesn't, go back and recheck this math here. If it does match, proceed on. Distribute it to the next term. So 3x to the second to a negative 4. So we end up out here with a negative 12x. Again, come through and subtract. So 3x to the second minus 3x to the second is 0. 4x minus a negative 12x. So again, put these two, this minus and this negative together, it's a plus. So negative 4 plus 12 is going to get you a positive 8x. All right? Now come back in, pull the next term down. So we end up with a minus 30. Again, come back over here underneath your dividend, find that first term that came out, that 8x, and divide it by the first term in your divisor, which is x again. And this equals an 8. So we'll come in here and we'll put that plus 8, that positive 8 above the term. And we're going to distribute it in. So 8 times x gives you 8x. Stop. Make sure they match. Remember, they need to clear down to a 0. If they don't, come back over here and check that math. Right? Then the 8 times the negative 4 is going to get us a minus 32. All right, now we're ready to do our subtraction. So 8x minus 8x is a 0. A negative 30 minus a negative 32. So negative 30, put these two together, plus 32. So negative 30 plus 32. Opposite, so subtract them. So that leaves you with a 2, and it's a positive 2. Now we don't have anything else to bring down. So like in long division, this is our remainder. We always take our remainder and put it at the end of our problem and put it over the original divisor. So in this case, it's going to be a plus 2 over x minus 4. So our final answer is right here at the top. Our final answer is 2x to the second power plus 3x to the second power plus 8 plus the remainder of 2 over x minus 4. This is our final answer.